Welcome to 7.2. What effect does the positive, negative, and the constant a have on a graph? So it's right out front here that we're looking. We're just trying to figure out what effect does that have. Okay, the parent graph, f of x equals x squared, is graphed right here. And now we want to show you, it's just like the absolute value. Hopefully you were in class studying on that part. It'll be a nice review for you. Remember how we get the parent graph is we actually plug in 1 squared is 1. Well, when we do the 2, when we plug in 1, we've got 1 squared is 1, but then we need to multiply by 2, so the value of 1 comes out to 2. And when we get to 2 squared is 4, we have to take that 4 times 2 still, so it comes way up here. And the 0 squared is 0, 0 times 2 is 0. So you can see by symmetry what has happened to our graph when we have that whole number in the front. Okay? Now, if we have a fraction in the front, again, we would have 0 times a half is 0, but when we come out with the with 1 from our parent function, a half times 1 is a half. And when we have 4 for 2, because 2 times 2 is 4, 2 squared is 4, times a half, it's 2. So you can see with the fraction, getting the other effect than this whole number was. And it's real important that you get a few vocabulary words connected with these. When it's a whole number, I know you guys like to look at that and say it's skinny. But mathematically, we look at the distance that has, what has happened on the distance from the x-axis. See how the blue line is here and the green line's up here, further from it? So we say that it's stretched. It's been stretched up from the x-axis. Now on the brown line, we say that it's been compressed, it's been pushed down, or you might see the word shrink. Usually you'll see compressed and stretched for those descriptions. Now there's one more description that you need to become aware of, and that's if there's a negative up front. 0 times a negative is 0. But when we come out with the 1, 1 times a negative is negative 1. And 2 squared is 4. 4 times a negative is negative 4. So what this has done is it's taken the blue parent function and just flipped it straight over the x-axis. This is called reflected. Sorry, it doesn't want to write down there. You can write it R-E-F-L-E-C-T-E-D. Reflected. Okay? So what's happening to the domain and the range in these? When it was 2x squared, the domain doesn't change. It's narrower, but it's still going to go on forever and ever. So it's all real numbers. I'll give you a hint. As I said before, domain never changes on quadratics. Okay? Now on the range, y is greater than or equal to 0. Because if you think about it, there is 0 for the k. There is no k, so it's a plus 0 out here. And I said the y is always connected with the k. Same thing here. The lowest point on the graph is 0, so it would be y is greater than or equal to 0. K value is 0. Now here the k value is 0, but look, your 0, 0 is your highest point. So you need to flip this inequality around, and it goes that way. So anytime you have a negative, the inequality has to be less than. When it's positive, you've got the greater than inequality. Write an equation for the graph. Well, first thing we know is that we've got a point here that we can plug in, and if we can plug in a y and an x value, then we can find our a. So here's our x, here's our y. Okay, so we plug in a -1 equals a times 2 squared. We just plug it right into that equation. -1 equals a times 4. Get that a alone, draw your line, circle your creepy dude. He's being multiplied, divide. -1/4 equals a. So now plug it into your equation. You would say the equation for this graph is y equals -1/4 x squared. Does that make sense? Well, it does look like it's a little bit wide there. It also appears to be upside down, so the negative does make sense. Remember, math always makes sense. If it doesn't, then we need to talk some more. Parabola has a vertex at 0, 0 and passes through -2, 2. A student says, this is the graph. Do you agree? Well, let's go to our formula. We have y equals a x squared. We know that it doesn't have an h or k because they gave us the vertex. You should always ask yourself, why would they give me that? That's because there's no h or k. Now this is our x, this is our y. So we have 2 equals a times -2 squared. -2 squared, -2 times -2 would be 4. Divide by 4. And we find that a equals 1/2. Okay, so we know that he has the 1/2. We agree with that. The only thing we need to double check is the negative. Let's think this through on a graph. 0, 0 is our vertex. -2, 2 is the point they give us, so it's -2, 2. There's no way that can be a negative, is there? If that's our vertex, this is going to flip over that. We just need to correct him right here that that's a positive. He's done everything else correct. Okay, see you in class.